Hi guys, so we have this question on fluid mechanics which reads, a jet of water squirts out horizontally from a hole near the bottom of the tank shown in the figure below. The hole has a diameter of 3.5 millimeters. What is the height h of the water level of the tank? So this is the illustration of the diagram that we have. So what we're going to do is this. Let's start off with the Bernoulli's equation. So according to the Bernoulli's equation, let me just write it here. Rho gh, that's h1, plus half rho, this is v1 squared, this is equals to p2 plus rho gh, that's h2, plus half rho 2, that's just rho v2 squared. Okay, so to make this easy, we can say, let's assume that the water was coming out at the bottom here. Let's assume that the water is coming out at the bottom here and it's going in that direction. So if this is the direction of the water, what we're looking for is the height. Now to find the height, let me just indicate it here. This is the height that we're looking for, h. Now to find this h, let's first break down the question. We can see that this water is exposed to the atmosphere, right? It's open at the top there. Then there's water at the bottom here as well. This water is also exposed to the atmosphere. So P1 and P2 is just atmospheric pressure, and this will just cancel out. So I can have it as P1 minus P2. This will cancel out. So what do we remain with? What we remain with in this case is rho gh1 plus half rho v1 squared. This is equals to, on the other side, the only thing that remain with here is rho gh2 plus half rho v2 squared. So since both pressures are exposed to the atmosphere, so both of these have atmospheric pressure, so they can just cancel out. So now the water, before it started flowing out, this water was still, meaning that it had initial velocity, which is v1, being equals to 0 meters per second. So the initial velocity before it started flowing was 0 because the water was motionless. And because of that, this part here, which has a v1, will cancel out. So if that's the case, we can say rho gh1 minus rho gh2 is equals to half rho v2 squared. If I factor out rho and g here, I'll have rho g, open bracket, h1 minus h2. All this is equals to half rho v2 squared. Density can cancel on both sides, so rho cancels. If density cancels, these two, if I multiply the entire equation by 2, I'll have 2g. h1 minus h2 is simply the change in h. And this is equals to v2 squared, like this. So now, this velocity that we have here, our v2, is equals to 2g h. Now the h we're talking about here is this h that we have there. So this velocity 2 is given by the square root, because it's a square there, so it's just a square root of 2g and h. And this is the equation of velocity of a flux. Okay, so now that we have this equation, let's just remove everything and see how we can calculate this equation. So since we're looking for the height, we're looking for the height h, we're going to make h here the subject of the formula by saying 2gh is equals to v squared, right? So if I'm looking for h, this implies that h is equals to the velocity squared divided by 2g. So this is the equation we'll be using to find the height. This is coming from the velocity of a flux. So now, what we're interested in here is that the velocity that is coming out at the bottom here, we need this velocity. Now, this is velocity in the x-axis, or this is the velocity of the water coming out in the horizontal. So we're going to apply some concepts of kinematics to actually find the value of this velocity. What we need to take note of here is that the displacement here is 1 meter, while the displacement here, which is x, this is 0.6. So this is what we have. In the y-axis, or let's say in the vertical axis, remember we're looking for velocity in the x-axis. So in the vertical axis, the initial velocity in the vertical is 0. Why? Because initially this water was moving in the horizontal. So in the horizontal, we just have v as it is. We don't know what that value is, and that's what we're looking for. So what else do we know? We know that in the vertical, acceleration due to gravity is 9.81 meters per second squared. Also, in the vertical, we have the displacement, which is 1 meter. In the horizontal, acceleration due to gravity is 0. There is no acceleration due to gravity in the horizontal, and the displacement in the horizontal, we've been given 0.6 meters. So, how can we combine these two concepts? So the only quantity that is the same in both is actually time. So I can simply say, let's find how long it will take. Then once we find how long it will take in the vertical, we can apply it in the horizontal because the time will be the same. Then we can find the initial velocity there. So to find the time, the equation we're going to use is this one here. Displacement is equals to initial velocity times time plus half at squared. The displacement in the vertical is 1. Initial velocity is 0 plus half. Acceleration is 9.8 t squared. So this is what we get. So this is 1 being equals to 4.905 t squared. So let's see what we get as a value of time. So we're going to say 1 divided by 4.905. Then the square root of our answer. So get the value of time to be 0.45. Let's say 0.452 seconds. So you can put the time value here, 0.452 seconds. So if that's the case, the same time is the one that we're going to use here as well, which is 0.452 seconds. So to find the velocity in the horizontal now, we can say, using the same formula, we can say x in the horizontal is equals to initial velocity times time plus half at squared. So x is 0.6. The initial velocity, this is what we want, multiplied by time. Time is 0.452. Acceleration is 0. So this is just a 0 like this. So the initial velocity in the horizontal, we're going to say 0.6 divided by 0.452. This gives us 1.33. So the velocity is 1.33 meters per second. So this is the value that we have here, 1.33 meters per second. So now that we have the velocity there, let's find the height. Remember, we had already derived the formula for the height, which is what we have here. So let's just drag it over here. We said height is equals to the velocity, which is 1.33 squared, divided by 2g. That is 2 times 9.81. So let's see what we get as a height. So 1.33 squared So 1.33 squared divided by 19.62. This gives us a height of 0.09. So height 0.09 meters. And this is equivalent to 9 centimeters. So there we have it. That's the value that we're looking for. So I hope it makes sense. Thank you very much.